Hi. Hi. Yeah. Good. All right. So, hi everybody. I'm Amin. Yeah. And it's nice to see you here. First, my apologies to who has heard this talk a little bit of it. At least I tried to change it. I haven't been that maybe creative as I should have. I'm mostly most of my career I've done React. So I'll call myself React developer, a full stack developer now. It's pretty weird that it's my first time here. So I've been living in Montreal. It's over a year. I've never been to React Montreal. So I'm very happy to see you here. And so this talk basically comes from, can you hear me? Should I? Yeah, okay, good. So this comes from a very real case thing. The problem I faced, not problem, but a thing that I faced in different teams I worked at. And it was basically automated testing. So why everybody says, oh, it's a very good thing? Is it really a very good thing? And why not so many teams do that? As many as me may think. So basically I brought this talk up, and the main purpose of this talk is basically me sucking all the information out of you. So please step in whenever you want, and we're gonna have a microphone, right? Hopefully, yeah. Or you should be very loud, yeah, thanks. All right, so yeah, I told you I'm a full stack developer, mostly I've done React, and I love optimizing things. I'm very curious, if not nosy. So I really like learning new things and going here and there and learning about the things that aren't really maybe the subject of the thing. And yeah, I watch a lot of sumo wrestling. If you don't know what that is, just go check it out. It's fun. And I'm here basically for your ideas. So this is somehow the agenda. We're going to see how it goes. What is testing, and why do we do that? And what happened, a little bit of history, my take on it, my take on the problem, and what I think could work best. So, testing. What is it? Basically, so in every manufacturing area, when you make a thing, when you want to sell it, before you get the money, it has to work. You have to prove that it works. So you have always testing upon delivery, which is a part of basically the contract. You also have periodic tests over different things. Does the thing that I made a long time ago still work? Is it working as it should? And you also have testing during the development. When you're making things, that's what we're talking about doing. And we're talking about software. We're not talking about, it of course is a fact about every manufacturing process. But what we're talking about tonight is while we're developing things, how do we test them? And how do we automatically test them? And why would we do that? And what people think about it. So, what would I define automated testing during development? So basically you have, we write a feature, we make a feature, we create it. And then what happens is that every time we have to go over it, click it, trigger it to see if it works or not. Does it work as expected? See the edge cases. So if we do that not only manually, which manual testing is a big part of testing in software development, is its career. If we do not do that manually every time, that might be better. So if we break things with Node, without an expense, we just run the test suite, and it's just going to tell us, where it's broken. So that's the basic idea. So basically, we want to break things less frequently. So we want to develop faster. So we want the development process to be easier. And as a result, we want it to be cheaper. So the whole thing, if we zoom out a little bit from the technical point of view, we're solving something and to make some money, in the end, to create some value. And testing, automated testing during development, is a thing that is supposed to help us achieve that. So these are somehow the basics that I'm going to return to a couple times. So, for example, you always have heard of linters, for example. Linters are that very like testing tool, I might call it, that just goes up and sees if you have written things correctly or with a standard or not. And it's automated, so it's cheap, and everybody has to comply with it. Yeah, like TypeScript, for example, linters. TypeScript just checks things and tells you right in the ID, like, is it correct or not? So you do not break it. And you have also tools that do automated testing, like Vitess, Jest, Karma, Cypress, you name it, Playwright, Selenium. So these things are basically cheap labor for you that you set. You give instructions to, and they would run it anytime you want. And they would tell you if something breaks or not. One thing, so writing tests takes time. It's a hassle. You have to keep them. You have to maintain them. Sometimes they break. You have to go there, and it's programming that has been done, and you have to just go firstly discover what's been written there. What should I change? Am I allowed to change that? It takes time. So it's always a question that should I really write test or not? What is that I cannot really replace by precise human experience? I've seen a lot of people saying that. Yeah, I've seen a lot of great projects failing with tests. I've seen a lot of projects that made a lot of money without a lot of tests, and that's right. It doesn't mean that if you write automated tests, it's a guarantee. It's just supposed to help us for a cost. So I've asked myself a lot of this question, and this is a question for you also. So if you just keep it in mind, and when like after a talk or whenever you think it's best, I'm gonna hand you the microphone. Like, what is it that automated testing does that humans can't replace? My answer for it is regression. So what does that mean? It means that, just imagine we have a project where 80% of the features that we had to develop. We've been doing this for 3 years. We've changed like 2-3 developers on the way. And now I'm going to add another feature. And well, I added. How do I go back and check all the other features that I have developed to see if any of them has broken, has been affected? Humans don't do that. You can do it, but humans tend not to do it because you have a lot more to do. You're always looking at the next thing that you have to do, at the next value that you have to create for the company or for the project. So as a result, it happens a lot that if you go to my experience, if you do not invest in automated testing, you will see that your features would regress. They would break. I mean, things that you have already made and worked perfectly, delivered, you got the money, and everything's fine, they're gonna break. And you'll know during production. So this is the only use that I see machines do better than humans, because it's boring to do. I mean, going back and learning all those things. Whereas if you had already set the instructions for this cheap labor thing, machines to do that for you, they would do it. They would carry it out every time exactly like the previous time. So again, when we write tests, it's a hassle. It's work to maintain, to write, and all of that. But the most important thing is that it should bring you less work. It should bring you better feeling towards the project, and it should, of course, increase your overall speed. Here, I'd like to go a little bit on the history of automated testing. It's a very old subject, and right now nobody talks about it anymore. But I mean, the hype of it was maybe like, as I look at the literature, in the middle of 2000s. So what happened back then is that Robert T. Martin, you know, this big name, right? The Joint Manifesto, TDD, all of that. So he had a thing. If you look at his ideas, he always says, for example, he says the Joint Manifesto is for discipline. So it's not that, hey, let's do, no. He's very judgmental, maybe he's very educative of a figure. So he says that he introduced this approach that whenever you want to write a feature, in the blocks that you think, not in the biggest blocks. So you say, for example, I have a button and I want this button to pass my unclick. Okay? So what you do is that firstly you write the test. Say, there is a button, you render it, oh, the test fails. Why? Because there is no button. So firstly, make the button. So you make the button, the test passes. And then it has to pass the unclick. Oh, it doesn't do that. Why? Because I haven't written it. So in very small pieces, in very dumb pieces, just enough to pass the test. Basically attacking the problem from the side, not going exactly in the middle right away. And he called it test-driven development, TDD. So the thing is, normally when you write TDD, you end up with a lot of tests. A lot. Like maybe like more than half of your code base is tests. But the thing is, that's not the real, what happened. The thing is, Robert Martin, Uncle Bob, they call it, he's very entertaining as a person. So the thing is, he brings a lot, and we're humans, we're not machines. So we like and dislike things emotionally too. So the slogan he stood for was that you are not a professional developer if you ship a line of code without automated testing. He says that over and over. Some people may not agree with that, but it became sort of a fad. It became the idea that, hey, if I write tests, how about you? That kind of thing, rather than a practical approach. Anyways, he had points, and his main point was that you have to have tests for everything so that you can refactor. Because I think we've all been there, that we have the code base that we can't really touch. Don't touch it, right? And he says that cannot happen. That means that that's the end of the life cycle of the software, and we'll have to write another one, another piece. And I don't know if maybe the market likes that idea, but we've seen a lot of projects that live only for 5-6 years. We've seen so many projects that live for more. So the pushback came out. Of course, that was an idea. Again, it was professional, human and emotional. So people started saying no. So people said, I mean, come on, you're not writing an unclick for a button. What value does that bring? I mean, what's the possibility that I do not pass my unclick to my button? And of course, some code bases have around 60%. The code bases that use TDD have maybe like 60% of their code base in tests that you don't really understand. Some of them are redundant, and it takes time to write them. It takes time to maintain them. Should they really pass it or not? People make them pass instead of having them testing real things. And maybe one of the most important points of the people who are against TDD is that they say you're not writing with the goal of solving the problem in mind. You're writing just to pass the tests. That's in the end maybe. I mean, that could change the architecture of software. So there was the hype and there was the pushback. And I love this guy. I don't know. He's not even a superstar. He's just so cynical. I love this. he's so negative when he says that he just likes to destroy people. So he says that this is a post. Somebody said that when I want to hire people, I put some testing in their code. How do you call it? Like hacker rank stuff, like your code example or your example. Let's call it test. And he says, I put some testing in it, and when people don't do it, it's a no-no. It means that they've never done it. What he says is a very good point. He says, if testing is anything that's worth thinking, then it's wrong. Because it should be simple. Otherwise, no one would do it. Or imagine you have to maintain that too. And Jan Cooper has a very good talk. It's called TDD, Where Did It All Go Wrong? And he has, there's a very cool talk. It's around an hour. I really enjoyed every minute of it. And he says that some of his colleagues have more than 60% of their code base in tests, the ones that who do TDD. And so I was looking around and I stumbled upon this guy. I can't read his name properly. It's Brazilian, so if can anybody read that?
Maurício Anici.
Anici, did I get it right? Okay, great. Thanks. Thank you. So he has a very good book called Effective Testing. It's not only enough that you write tests, but I mean, is it effective? Are you really doing something? Or are you working on one of those many projects that had testing and failed? So he says that tests should be development enabler. Basically, it has to help you to develop better. So if you do that, so this is a very good example. I mean, I wish I had the code snippet, but I wanted to keep it short. This is a very frequent example. This is a very frequent thing that you see in React code bases. So if you start telling people to write tests during development versus not, your code base ends up less decoupled. I mean, more decoupled. So you're going to have less spaghetti code if you tell people to write tests. Why? Because they have to individuate each piece. They have to basically make it more granular. And if you do that, of course, it's going to help also development. The second thing was basically that this design by contract idea, and which you basically imagine the thing in different parts. And these different parts, module, components talk to each other, and you control, of course, this idea. Like, are they communicating clearly, correctly, or not? And of course, it has to be maintainable. I mean, writing tests has to be easy. No one will do it. So this is that an issue. I don't know. Romanian is not good. So he says that he talks about basically if you have a component, if you have some React piece which is in front of you or more or anything else, you'd better test the behavior, not the implementation. So you want it to do something, so you just let it do that thing, and then you measure if it did it properly rather than how did it do that. Like again, the example of the button. If on-click passes or not, that's not what interests us. That's not what is bringing us money. What bringing us money is that if I click that thing happens. So let's measure that. And so he introduces different stuff just to basically to measure how effective your testing is. And there are tools like Stronger.js. It basically tests your tests. It changes the scenario and your test. It changes the thing, the module you're testing, and your tests have to fail. If they're not failing, it means that the tests they're too gracious. And and of course your failure rate in your CI respecting the mean time to fix it. So just imagine that you have some problems in your pipeline. you get some bugs, and how much time does that take for people to fix it? If it's quick, it means that your developers are trusting the tests. If not, it means that they're not really trusting it. And how many bugs do you see in production that should have been actually caught before? That's another indicator. And if you change the code and you don't change the tests, and the tests are passing, that's not a good sign. And test coverage. So what we know of test coverage is that how much of my code have I tested. But actually, this is what Amin told me, which is a pretty cool thing. Coverage is basically how much of your code is being run inside your tests. It's not that how much of it are you testing. So basically, the code coverage is not the only thing that can indicate how good your testing is, even though that's the most popular number that you have. We have 80% coverage, code coverage, and we have a lot of bugs in production. So that's why. And of course, number 6 is whatever you told me. Yeah. And so I started sort of thinking, again, back to my personal story, so we had a lot of regressions. This is what happens. After a year of working this complicated front-end app, full of events, and it was only one page of drag and drop. You have every event in the world and every feature in the world that you want. And it started just being inconsistent because we also started changing solutions for state management, for example. A part was the URL. Another part, then Redux came in. And then we started keeping things also on a different node server. So these are the things that happen during development. I mean, you can't really help it. You start with an idea and then you change it. So we started having a lot of regressions. And we started seeing regressions of the features that were fairly simple. We had tested them a lot of times. So I started sort of asking myself this question: why are we not using automated testing? So I basically started. I'm a mechanical engineering grad, so I started thinking in terms of mechanical engineering. So basically, in mechanical engineering, we have when we want to see a model, we isolate it from the world, then we see whether it moves or not. For example, that's a box, or this. I'm trying to move it, it doesn't move because just the friction is as much as the energy I'm putting in to move it. And there is a beautiful paradox. Because if the sum of the energy is zero, sum of the forces are zero, then that thing doesn't move while we're isolating. There's a very beautiful paradox of the horse and the carriage. It says, of course, as much as energy, as much as force, the horse is inflicting to the carriage is inflicting to the horse. So if you see, that's basically zero. The sum is zero, but it's moving. It shouldn't move. It's moving. So the answer is that we are not seeing the subject law. We are in the first part of our mind, of our discourse. Our paragraph starts with, I'm considering only the carriage. And then the second part of the paragraph goes, no, I'm considering only the horse. So basically, we're not isolating the right thing. So it's a very frequent idea to basically change what we call control volume. Change the perspective, change your subject. Maybe it's not this exactly, it's something else beside it. So I started thinking that maybe the problem isn't coding, it's humans. So I started thinking, why would humans not do testing, automated testing, even though it's a good thing to do? And I thought of course, there's a lot of history in here. We can talk about a lot of things, but mostly we know that for people who started going to boot camps and out of this this wave that I think I consider myself one of the people who learned programming that way. There was so much rush that nobody basically cared about discipline or automated testing or stuff like that. When you told people about automated testing, they were like, wow, you're thinking too much. Or it would sound more like a luxury. So people did not have the opportunity to learn that thing as a practice. And well, I thought of this book that I really loved. It's called Atomic Habits. I still have this type of it. Yeah, nice. So basically, it says that if you want people to do something, there are 4 stages to do that. First, they have to notice it, have to see it. For example, if I would eat a cake, it's more probable for me to eat a cake if it's in front of my eyes. So if I don't want to eat it, I better put it back. Like I better put it somewhere I can't see it. The second thing is that it should be attractive. It shouldn't be a pain. The third thing is that it should be easy. And it should be satisfying after you do that. Now get all this work and just think about the projects that you've been doing in big teams and see how automated testing would fit this. Not a lot of my experiences. So I thought maybe to put it in front of people, I would just add to my script the running the test running suit, like npm run test watch. So with that, when I say npm start, I would add that to also to my script. So everybody would see that and determine, well, something is coming up. So what is this? And I think it's useful to make it a part of your engineering brand, saying that, hey, this is how we do things here. It's not a big deal, but we do it. And don't make it look like programming, because it should look very simple. Don't say that, hey, listen, we do testing, so we're gods. No, it's a simple thing that you can do, everybody can do. It takes only 5 minutes to write a useful test. And the feedback loop. The thing is, if you ask about it, if you think about it, if you talk about it, if you promote it as a thing, it's more probable that your team would adapt such culture. And yeah, I remember when I worked at Morgan Stanley, we had a lot of legacy code, and they didn't have tests. So they wanted to enforce testing, so they said, all right, whenever you change a file by some links, all of it has to be tested so you can merge it. So basically, if you had, this is pain, like I'm talking about Python scripts that were like 10 years old, and our CI/CD guys were going into that and touching something, all right, you have to write tests for all of it. Now, how effective that is that, how actually that would safeguard something, that's a different question. But that's how they enforced it. So I think if you have like incentives, that would be better. That would be smarter if you want to build a product that's a little bit more stable in the long run. I think it's better to have smarter incentives. And I came up sort of with the idea of my ideal test. Like, what would I do if the world was perfect? If I had enough time, money, resources, what would I do? Like, how would I write tests? So, the first thing is that I want it to be very easy. I want it to be readable, changeable, and I want it to be extremely modular and isolated. So this thing is pretty. I think it takes a little bit of. It could take a little attention. I was talking to people just before the talk. So I was familiar with the fact that, all right, if you have a React component, for instance, say a very generic table of contents that you get. I mean, you fetch a JSON and you just show it there, right? If you want to test that, of course, you have to isolate it. You have to imagine that the response is correct, because if the API breaks, your test would break otherwise. So we have the API and we have the component. I want to test this, not this whole thing. So I have to imagine, I have to intercept this call and put that JSON in and say, hey, listen, imagine this is perfect. And then, now if something breaks, it's this component. What Thibault told me was that his team also mocked, basically isolated this parent component from the child components. So basically said, all right, listen, all the child components are doing well, do that. So that's a different thing. That's also a very great idea. If you know what you're doing, if you're sure that all those things are working well, solely and together. The second thing you really want from your test suite is that to be indicative. Just imagine if I have like 3 macro, like big components, and I have tests only for each of them, and this one breaks. I have to start dissecting to see what happened, to see what the problem is. But if I have tests well placed over exactly where I think could be problematic, could be error prone, then I would be able to just put my finger on it. All right, this happened, and then we can go back to that indicator, that metric that Mauricio Nietzsche proposed. Is at the time that something breaks in your CI/CD versus the time that it takes the time that it takes developers to fix it, because dissection is a part of it, of course. If you dissect, if you know where the problem is, basically you're maybe at 80% of your solution. And so I want it to be also fast. It means that if I have in my CI/CD, I don't want it to run for like 1 hour every time I want to deploy something. So I want it to be quick, I want it to be light, and especially about front-end apps, React components especially, they're heavy to mock. They're really heavy to mock. To every time say that, all right, I have this, render this, then these tests fine. It's a very difficult, it's a very time-consuming thing to do. And honestly, if you look at this, you can just makes my life easier. You can put that how code should look like, not only testing. It's also right about anything piece of code that you write. So the suggestions that I came up with in the end is that obviously I'm not a fan of writing tests for everything. Obviously, I'm a fan of writing tests for what matters. And I think the ticket, your Jira issue or whatever that you get, that is your test basically. You just have to translate it into code. I want this happen to that way. Great, tick. All right, I'm gonna do it this way. And honestly, unless that thing breaks, your code is good. So you don't need to test every piece of implementation. And talking about LLMs are great at doing repetitive things. They're very good. They're very good at writing tests. I think that it has made our lives much easier. But they tend to use a lot of brute force solutions. Basically, just make it work with the least efficient way, but just make it work. Mock a lot, run a lot of things. As far as it works, we're happy. And maybe that's not the optimized thing yet. Maybe they're going to get better at that. I think they will. But until that time, you have to just get that, like exactly what you do with your code. Just take that bunch and just work on it a little bit, make it more efficient, or put in more prompts. And you need to know what you're shipping. I think you need to know what you're shipping, or it's going to be legacy day one. And in the end, what I think is that when somebody gives this piece of software to you and says, hey, I want to ship it, and you just say, all right, this has to work this way, this has to work that way. So that can be a test suite. Basically, you have to automate what you've been doing. You have to automate what you would expect as a human from this piece of software. Another, like some more questions that came to my mind is basically testing LLMs or I'm sorry, I'm just the penultimate one. So you can write basically customized LLM context for test writing. But we're doing with everything. I think there are LLM contexts for test writing already out, and I think it's worth it to take a look at it. And also, the fact is that how would you automatically test LLM in this sense? Because LLMs don't have 100% correct results. What we have for now is very assertive. It's just very like 100% yes or no. So I think that's something that in the future would be pretty cool to face. Yeah. And the last one is yours to fill. Does anybody have any opinions, any queries? Wow, that's great. Lovely. Thank you.